Since we've been here, and it's been over a full year now, of course, since we've had RAPID, there's been quite a few different things that have come through in different industry sectors. We've got a great view here on what's on this table, and we can walk through a couple to show everyone. What's really exciting for me since the last couple of years that I've been in the industry doing this, especially for post-processing, is that the medical industry is really growing exponentially right now. We're seeing a bunch on the table as we have it here. We've got anything from these different types of braces, knee braces, joint things. We have cranial helmets. We also have products like this that are on the lower limb. Here we have this unique knee brace. This one is really exciting because it's also using a PowerShot S finish. That gives us the ability to create a scratch-resistant surface, so we have a little bit more durability on an application that's very clearly going to be used quite heavily. And on the inside, it's a little bit different because we're using an adhesion process to have a different direct-to-skin contact of just a different foam that they're having. So the exterior component that's printed is what's really unique because it has to be done during printing, so it's unique to every single patient. And of course, speed of production here. This is a really incredible device developed by Quorum. They are printing with the HP technology, both in a PA12 and also in an elastomer. And then they are doing a vapor smooth finish on the interior, strictly to create a better suction and feel to the user of the device. This is actually one of their unique patented devices that is called the Quattro. There are other components that go in here that then uses a special BOA constricting device that then tightens onto the user. But the suction is what allows a better fit and feel to the actual patient themselves. And then of course we have a standard socket that can go underneath on the bottom end there. But really, really cool device, and the reason that we're doing printing on this and the reason that they're doing printing is so that they have these internal channels for the BOA lines to help constrict and tighten down on the patient, but also to create unique geometry specific to that patient themselves in a very rapid real life scenario. A few other really great ones on the table that we have, as we just mentioned on some of these helmets. This is really up and coming as we talk about it. Autobach right here has already been pushing out this really cool design and a single locking closure on these helmets for infants and small deformities on their skull structures. Also, as you can see, using HP printed technology, finishing it through DyeMansion post-processing, and giving that ability to create colors developed for the users themselves in a few different varies. One of the really exciting ones that we've had over the last years is this BAUER Reakt helmet. BAUER, of course, as we all know, is an extremely popular hockey brand owning most of the market. So BAUER came out with a unique lattice design that allowed more airflow through the helmet, allowing the athlete to have a cooler playtime on ice. Printing was the only way to create such a lattice structure. Then we had a few other requirements. Of course, we have to worry about how is it going to react on skin with perspiration, movement, fit, feel, direct-to-skin contact. But also, of course, protection. At the end of the day, it's still a helmet. It still has to be on ice used during the games, not only for the athletes themselves, but also for the referees. So a few things came into play. BAUER, EOS, and a few other folks, including ourselves, were very heavily involved on this project. Already launched and used by athletes on ice today in gameplay and available to consumers. For our end, which was really exciting for us, is that we were able to utilize all of our different technologies. For the most part, we were able to use a cleaning device through our PowerShot C to automate the cleaning cycle to really speed up the process of development time. Then we ended up using our vapor fuse technology to create that totally sealed apparatus so that it could meet the specifications around perspiration and also feel and comfort against the skin. And then finally, we used our DM60 to create that blue color on the inside that met the requirements of BAUER and the athletes. This also opens up the scope as we move farther because the printed component, as we see it right here, is a white-based TPU, which gives us the ability to hit many different color scopes. So blue is a starting point, and we can use our imagination, of course, from there on of where that could take us and how we move forward. This opens up a whole lot of different doors because helmets are not just used for hockey, of course. They're used for consumer products through all different categories, and then protective gear in general goes all throughout the whole body. So it really opens up a huge opportunity of different companies, different brands, and different industries, not specific to just athletes right here. So it's also really exciting as we come into the new markets are materials like ULTEM. ULTEM is used usually in different requirements that need higher elevations and temperatures, and maybe even different areas like aerospace. For us, what's exciting is that we're able to utilize our PowerFuse S to actually smooth that surface completely. So we can use now this product as maybe an air transport tube or even a fluid transport tube in some of these components or transport vehicles like aircraft, where ULTEM is the required material, but when it's in its porous state, it can't be utilized really as one of these transport tubes. So through vapor fusing, we can smooth internal channels completely, utilizing the PowerFuse because of its extremely strong vacuum pull and the iterative process that we have with our solvent. We're taking that even a little bit further into other polyamides here, like you see on this table. This is just a small scale version of some header pipes, for example. As you can imagine, a really challenging design here with this unique organic shape and geometry of the inner channels. Using the PowerFuse is really the only way that we can clean all of these internal channels and seal them completely so that this could actually be utilized as an airtight function. Something like this could be used as maybe a compression test or an air test. It can even be put into a full-scale model to simulate real-life scenarios and then go into a production phase from that point on. Pushing that further just on new materials that we see coming through that utilize same end products potentially is polypropylene. Polypropylene is up and coming in the market right now through several different material companies and of course printing technologies. The biggest roadblock today, besides of course volume and application, is how do we get a better surface treatment. Polypropylene is a very chemically resistant material, so it does require us to try and tackle it with a different process. So we developed a very unique smoothing process utilizing our PowerFuse S PP, so a polypropylene focused PowerFuse, and we're able to create a completely sealed product. So similar process as we're doing as our PowerFuse, as we explained a little bit earlier on some of the other applications. But this allows polypropylene to now enter the market to utilize some of these true fluid transport tubes and other applications that we see polypropylene really require. And what's even cool about that is we can take that part and still create a really good finished surface and create some strong dexterity to that component, allowing us to continue to push it through other market scopes. If there's any ideas that you have that come through and other industry scopes that you have, obviously, please reach out to us at hello@dyemansion.com. Reach out to myself and our team, and we'll be very happy to assist in every way we can.